All right, good morning, everyone. Welcome to STG314. Here we're going to learn about how Here uses JFrog Artifactory to support their CI/CD environment. So I am Young Kim. I'm a Storage Business Development Manager at AWS, and I'm joined here today by Suresh Prem from Here Technologies, as well as Yoav Laman, CTO and co-founder of JFrog. What we have planned for you today is a brief overview of storage at AWS, then a brief overview of EFS, Amazon Elastic File System. Then I'll turn the floor over to Yoav to go through an overview of JFrog and Artifactory. And then we'll move on to Suresh to share their journey with both Artifactory and EFS. We'll leave you with some references and some pointers to some other sessions here at re:Invent for additional knowledge on the subject. And then we should have about 5 to 10 minutes for dedicated Q&A, as well as the speakers will be around after the session for one-on-one Q&A. So let's get started. In terms of thinking of storage, and this is true both in AWS, but storage in general, we believe there are 3 ways that you should think about how to choose the right storage for any given application or workload. First, you want to think about how do you access that data and that storage? Meaning, what are the interfaces? What's the behavior of that storage or the semantics? What kind of permissions do you need for those particular data sets? Then you want to think about what are some of the key features and what are the performance characteristics of that particular workload. And lastly, you want to think about the economics. What's the cost of storing it? What's the cost of accessing it? So those are some of the key criteria that we like to think about in terms of choosing the right storage for your workload. So interface is access. Semantics is how it's represented. What do your users and applications see and experience? What's the behavior that you require? And then the permissions models. What level of granularity do you need? What type of access do you need to control? Okay? So today, both in AWS as well as in storage in general, there are 3 main types or categories of storage available today. There's file, block, and object. And we'll just quickly go through each one. So file storage is the most common type of storage for applications today, and there's very good reasons that's the case. One good reason is it's natively supported by operating systems. So operating systems can interface with the APIs for file storage natively. And it supports shared or concurrent access across multiple clients, which is another key attribute of the interface. So semantics. The file system supports strong data consistency, which means that when a client or application writes a piece of data, that it can be read, that last atomic, most recent update can be read immediately by another client. File locking, as well as a directory structure, a way to organize the data in that file system. And then lastly, lastly, permissions. Standard operating system model to be able to control the read, write, and execute permissions at the operating system level. Okay? So these are some of the key characteristics of file storage. And we think this is important and exciting for customers because up to 80% of unstructured data today is in file systems. Right? So this is a native way to support file system applications for your customers. So file supports file system semantics for standard operating systems, and it's multi-attached shared storage. Block So virtual disk, think of it as analogous to SAN or fiber channel storage, and it's typically single attach. And then lastly, object storage provides access to data via a simple API, and it's typically accessed over the internet. So let's think a little bit about relative performance. So with block storage, kind of going left to right, block storage will typically provide the lowest latency or response time, but is sometimes limited to single gigabytes of throughput in terms of scale. As we move up, file storage is typically slightly higher latencies, but also provides scale up into the tens of gigabytes per second. And then lastly, you can have tremendous scalability with object storage, and typically the latencies will be even longer. Okay, so this is just a relative comparison of how the different storage options relate in terms of performance. So for many customers that were looking to use file systems and shared storage in AWS, before, a lot of them were having to do it themselves. So what would that look like? So here in a virtual private cloud, you have a couple of availability zones. So customers would set up an EC2 instance, configure it as a file server, and allocate a couple of EBS volumes, depending on the capacity. But at that point, they would realize that they needed higher availability, and so they would oftentimes create a second EC2 instance with its complement of EBS volumes, and they would need to copy the data from one to the other in case of a failure scenario. So all of that needed to be configured, needed to be managed and administered by users, by customers. Until we launched Amazon EFS, Elastic File System. And Amazon EFS is a fully managed file service in AWS. So what are some of the key features? We made it simple, so it's very easy, simply a couple of clicks to configure a file system. It's fully elastic. There is no provisioning required once you've created a file system. It's available and empty. You simply add or remove data, and the file system will expand or shrink as needed. It's scalable, so as capacity grows, the performance will scale accordingly. And it's based on a foundation of very high availability, very high durability. All file system objects in Amazon EFS are synchronously mirrored across multiple availability zones. It's highly performant, again, when you think of that relative performance of the different storage classes, and it scales linearly, and it's fully managed. So all of the administrative burden and some of the costs associated with that are now abstracted by Amazon EFS. As mentioned, file systems are one of the most common uses or storage classes out there today. And we see it used for a wide range of workloads, all the way from scale-out jobs like analytics and certain media and application workflows to metadata-intensive jobs like development tooling, which we'll talk about specifically here today, and things like container storage, which is part of our case study. Okay? So anything from high throughput to low latency and serial I/O. And so it's no surprise that we have a wide range of customers. Of course, joining us here today on stage will be here, not only for development tools on the left center, but also for container storage, which is another part of their use case. So we have a number of different customers using Amazon EFS successfully today for a wide range of different workloads. A few of those are also presenters here at reInvent, and we'll be showing you and sharing with you some of the other sessions available for you here. Lastly, let me touch on security. So we mentioned permissions before, and EFS offers security at 4 different levels. We control the network traffic within a VPC using standard VPC security network ACLs. At the file and directory level, we use POSIX permissions. And then we control administrative access, or access to the API, through AWS IAM, for both action level and resource level permissions. And we've also recently introduced support for data encryption at rest, available at no additional charge, available in all regions with a simple click of the button. So I mentioned before, when you think about do-it-yourself, there's a lot of parts. And so when you look at the economics, the third kind of decision criteria for storage, these are some of the things that we think you should consider. So does it have any minimal commitments or minimum commitments and any upfront fees? Do you need to provision storage in advance? And are there other elements to billing? And in the case of EFS, we have simplified the economics as well. So there are no minimum commitments, there is no need to provision storage, and there are no other fees or billing dimensions. It is simply based on the amount of data that you store. Okay? And you can see the prices in the available regions down there today. So again, you could do it yourself. You could create this file server environment, pay for EC2, pay for multiple EBS volumes, and any inter-AZ data transfer costs to copy the data, keep it in sync. Or you could go with a fully managed option in Amazon EFS. And what we've seen in terms of total cost of ownership is that for this example, based on 500 gigabytes of storage, we are about 75% lower cost than do-it-yourself. Okay? So again, EFS, in this example, based on 30 cents a gigabyte, US regions, it's about $150 per month versus around $600 if you were to do it yourself. These are the regions that EFS is available in today, and many more coming soon. So with the introduction of Amazon EFS, we have completed and complemented the storage portfolio at AWS. So we have all 3 major categories now: block in the form of EBS, object in 2 forms, S3 and Glacier, and file in the form of Amazon EFS. And on the left, we have multiple different ways to get data both in and out of those storage systems. And then on the right, we have a number of different data security and management capabilities around those storage services. And with that, I'm also excited to introduce, a week ago, we launched a new feature for Amazon EFS, Amazon EFS File Sync. So for those customers that were interested in using data in Amazon EFS, but needed to migrate that data from on-premise or another in-cloud file system, we've introduced File Sync to be able to simplify and speed up that process. So you can connect it to both on-premise as well as cloud file systems and copy data up to 5 times faster than using standard Linux tools. And the setup is very easy and can be managed through the AWS console. So if you have any questions, certainly please ask at the Q&A or come see me up at the front after the session. All right, so with that, I'd like to turn it over to Yoav Landman, co-founder and CTO of JFrog.
Thanks, Jan. Okay. So Jan already introduced me. And what I would like to do now is give you a brief overview of Artifactory. and tell you a little bit about what Artifactory is. Just for my information, by quick show of hands, how many in the crowd are using Artifactory today? Okay, so the majority, which is pretty nice. So maybe just to start a little bit to tell you about JFrog. So you see the binaries people. We are often called the binaries people because we manage and deal with binaries. And those binaries are your software releases. Those artifacts is what you eventually ship to your customers, what you deploy on your production servers. And those binaries need to be managed. So a question that you may ask yourself, well, if you're using Artifactory, probably not, some of you already know, but why is it even a domain? What is the challenge of managing binaries? It's just files, right? So not exactly. So on top of the storage itself, so this session is about EFS, which is the storage layer. But on top of that, you need something else. You need an API for frameworks that need the API, like NPM, Docker, and so on. And you need indexes to be calculated, for example, in the case of YAM repositories and Debian repositories. And there is also a big booming of artifacts. There is actually an explosion of artifacts because of automation. So you keep generating a lot of artifacts that you need to clean up, that you need to manage in a way that you cannot do on a regular file system. And also, there are plenty of new ecosystems that pop up every now and then and become popular. And in this field of managing binaries and binary and package ecosystem, it turns out that people like to reinvent the wheel and write their own new packages. So somebody needs to take care of them and cater for the API of those packages. Where we stand in JFrog is we are the pipeline between your source control and your runtime. So in a broad generalization between your Git and between Kubernetes. And our products, they fill this gap, they fill this pipeline. We are focused on Artifactory here. So Artifactory is the hosting and management of binaries. X-Ray is for scanning your binaries for vulnerabilities, license violations, and actually any concern. And it integrates nicely with Artifactory. And Bintray is a distribution platform, entitlement, download management, statistics of your binaries, and so on. And Mission Control is just an oversight of the whole pipeline. And our mission is to make this pipeline as clog-free as possible, to make it really flow, make your software flow, and make sure that this pipeline is always green, never red, and you never have any issues with it. So that you can release fast, because if you cannot release fast, you cannot get patches out there, you cannot get new features, and of course your competitor will be there with these capabilities if you don't. With regards to Amazon, so we offer, I'm focusing on Artifactory now. We offer Artifactory as a hosted server, as a dedicated, highly available servers that we manage, upgrade, maintain, backup for you. And we also have a multi-tenant offering in Amazon, as well as other cloud providers like Google and Azure. And when we speak about the self-hosted portion, so what we're seeing specifically with AWS is that most startups, they start hosting their own Artifactory in AWS, and the rest of them is typically a hybrid. When they scale up, they become hybrid on-prem and cloud. And speaking about Artifactory, so Artifactory is a universal repository for binaries, for packages, for software. By universal, I mean that we support a big range of ecosystems. This is just a small example. We have over 20 different ecosystems that we support today. So you can see all the different package types. An installation of Artifactory in an enterprise can typically serve more than, we're seeing cases where a single Artifactory deployment serves more than 50,000 developers. But frankly, most of the users are bots. They are robots, not actual developers. On a single instance, we can see a throughput of more than 50,000 requests per second on a single cluster node. and tens of terabytes floating through Artifactory in any given day. And actually, Artifactory you can think about it as your DevOps database, because it really is the database. It really holds, and it's the persistence engine of your software. And for that, because this is such an important role, scaling is key. Like with any database, basically. If it doesn't scale up to your needs, you're in a problem. So in regards to EFS, so EFS is one example of scaling. But Artifactory actually has built-in mechanisms internally to allow you to have scaling. So EFS is just the storage layer. It's where files are being stored. On the right side, you can see an example of paths in Artifactory in the repository. Essentially, Artifactory employs a checksum-based storage, meaning that the files themselves are based on the SHA-2, on the SHA-256 of the file. So if you look at any EFS file storage, for example, with Artifactory, you will see this layout of the SHA-2 files, and the hierarchical characteristics of Artifactory are just in the application using a relational database. Sorry. It's an append-only storage, meaning that it requires some garbage collection in the storage to happen on occasion. And that allows us to scale very well because of this append-only nature and deal with high pressure in storage, such as big deployments or caching in a lot of remote artifacts, cleaning a lot of artifacts because we don't really have to delete stuff immediately. So that storage is one leading factor for scalability. Another thing that we have in the storage layer is an architecture of pluggable binary providers. So a binary provider is a very simple interface that you can write. And it takes care of storing your binaries. But by composition of binary providers, we can achieve a lot of flexibility in our storage backend. So think about eventual consistency when writing things, for example, to S3 with read and write behind caches. Sharding, redundancy, retries of storages that are not reliable, caching, and so on. So here's an example of composing. So this is a configuration file. It's advanced, so most Artifactory users will get it out of the box. But this is a caching, a storage definition for binary providers that allow this instance to handle redundancy of 3 shards with redundancy of 2 and retries for shards that become unavailable, and remote communication between shards, and so on. So this provides a great deal of flexibility. Another key feature that we have in Artifactory, and it's being used by most enterprise customers, is replication. So because you need to move data across the globe between different data centers, Artifactory provides out-of-the-box data replication. And there are 2 types of replication, push replication and pull replication. So with push replication, the premise is pretty simple. You deploy, your CI would naturally deploy an artifact to one instance. An event from that instance will push the artifact to one or more remote destinations. And to make up for any lost events or any networking issue, there is a process that is a little bit like rsync. It's an optimized rsync because it's based on full checksum replication. It will make sure to compensate for any lost events. Pull replication, which is quite new. It exists in Artifactory for about 2 months now. So the reason for those, by the way, is your network topology and what type of connections you can open between your servers. So in this type of topology, you deploy, again, an artifact to the source. There is a persistent connection that is opened from the target to the source Artifactory. On that connection, there is an event that tells the remote Artifactory to download rather than push and upload to it a new file. And because the remote Artifactory is also a proxy by definition, when you lose an event, you can either get the file to the destination on demand by a proxy request when you're just trying to download it from the target, or there is also this replication feature that compensates in an rsync-like schedule. Yeah, so another thing that we're seeing in the last couple of years is we're seeing a lot of consolidation being made around projects and tools in the DevOps ecosystems. And this consolidation happens because of automation, because you can do a lot more in a concentrated group. And in fact, we're seeing these groups that we internally at JFrog refer to as super DevOps. Usually they are very small groups, sometimes less than 10 people, catering for sometimes 10,000s of developers. They are not distributed in the most cases because they have to be really agile. And those groups, they need tools to allow them to make the work in a perfect way, because there is a lot of burden on their shoulders, and I'm sure Suresh from here will agree with me. It puts a lot of responsibility on those teams. And for those, they need tools that they have high availability, so their uptime is 100%, and you need clustered aware tools. You need serviceability through APIs, because you need to automate everything. And you need the ability to extend the tool beyond cases which you didn't foresee. So when you need a feature that is not out of the box in the tool, you can extend it, and this Artifactory provides using user plugins, which here are also using. Basically, this allows those groups of developers to drive this pipeline with the minimum impact on their productivity. And with that, I would like to give the stage to Suresh. And thank you.
I'd like to thank Yoa and Yong for giving a great introduction to both JFrog Artifactory and Elastic File System. Greetings to everyone, and thank you for attending today's session. During this session, I want to walk you through HERE technologies, experience with using Amazon Elastic File System with JFrog Artifactory in our continuous integration environment. My name is Suresh Prem. I've been with HERE Technologies since 2011, and I'm a principal systems engineer. My email is provided below. If you have any questions or comments after the session, feel free to reach out to me. I just want to give you a brief introduction about my company. HERE Technologies is a location-based company, and our vision is to enable an autonomous world for everyone. Mapping has always been about discovery. For centuries, two-dimensional maps guided us through the unknown to our destination. But we are no longer limited by the edges of our physical maps. In 1985, we began with a simple goal to digitize mapping and pioneer in-car navigation systems. Over the next 3 decades, as Navtech and Nokia, we have built a legacy in mapping technology. Today, we are creating living three-dimensional maps that grow upwards, breathing with layers of information and insights. We are reinventing the concept of maps and location intelligence to positively change today's urban modern life and to inspire innovative business development. To give you some context here, HERE technologies are in 4 out of 5 in-car navigations today, and we are mapping over 200 countries. We collect about 28 terabytes of data every day and combine that with our 30 years of transformation location technology to create a location-based future. Innovation and flexibility are key to our success. And the requirements for location-based platform are continuously increasing. We need to be able to answer the following questions. When is my package arriving? How long will the rain or the heavy rain on my route delay my arrival? Do I have enough charge in my electrical vehicle to take me to my destination, considering that I have my air conditioner on and I will be driving a lot of uphills? Even our definition of roads have expanded to include virtual roads in order to enable drone technology. In order to make sense of this vast amount of data and be part of this location transformation, we needed an IT and platform strategy to enable this. In our organization, we have a cloud-first strategy. Since 2011, we have closed about 8 data centers, and we are on the cusp of closing a few more in the coming year. We are a large customer of AWS and utilize our strategic opportunities in a number of innovative ways. And we have been doing that for 8 years. We use almost every AWS service in one region or the other. We also have decentralized the AWS costs for our business groups within our organization to have less bureaucracy and a better understanding of the financial implications and an opportunity to innovate. And the best practice I want to talk to you about is how we use JFrog Artifactory with Elastic File System. At here, we use JFrog as our repository manager. Artifactory supports multiple formats like Yoa talked about. It integrates with major continuous integration and DevOps tools. Artifactory provides an end-to-end automated solutions for tracking artifacts from development to production. Some of the package types that we use at here are npm, yum, gitlfs, and Docker, to just name a few. Artifactory is in the path of our production deployment, and hence high availability is key to having no system downtime. A key component of the Artifactory highly available architecture are, it requires a load balancer. The load balancer is required to distribute the requests to the different Artifactory nodes. It requires a file store, and this file store is required to store the binaries. And the file store needs to be available to the Artifactory nodes in both a read and write format. We use the database for the management of binaries and storage of the cluster-wide file systems. The Artifactory that we have implemented in the AWS cloud uses some of the common AWS services as seen in this diagram. This is an internal tool which is enclosed within a VPC. Users and CI/CD environments go via the direct connect to reach the Elastic Load Balancer. When we rolled out Artifactory in the initial part of, early part of 2016, we did not have Amazon Elastic File System available in the US East region. So we went with an NFS server solution. As you can see, it included the NFS server solution. What we implemented was, it had an EC2 instance. We mounted the EBS volumes onto it and then shared that as an NFS server solution to the Artifactory nodes. We have a disaster recovery Artifactory cluster solution in the EU region, and any artifacts that's written to the primary Artifactory is then replicated to the disaster recovery region. Like Yoa mentioned, we use the push replication. So anything that's written to the primary is push replicated to the disaster recovery Artifactory cluster. We ran into multiple pain points when we use this NFS cluster solutions, and I will walk through each of our pain points in the coming slides. And we use Artifactory RDS running MySQL as the database engine. So the Amazon Elastic File System was rolled out in November of 2016, and we migrated from our NFS server solution to the Elastic File System in January of 2017. So basically what we did was, we created an Elastic File System, copied the contents of the EBS onto the Elastic file system and then mount it to the Artifactory nodes. We use S3 as a backup solution, and we have written a plugin in Artifactory. Any Artifactory that's uploaded to the Elastic file system is copied over to S3 for backup purposes, and I will run through all our backup solutions in the coming slides. We store over 1 million artifacts, and we use about 21 terabytes of Elastic file system space as of today. We serve Docker images also through Artifactory. In this slide, I'll go through our journey of how we consolidated multiple repositories within here technologies to the standard Artifactory solutions. There are multiple islands of CI/CD environment within our on-premises data centers as well as on the cloud. And as a company, we decided that we needed to have a standard solution, and we decided to use Artifactory as the repository manager and to self-host it in the cloud. We did this in a multi-pronged steps. So what we did was, we are in the process of migrating the multiple repository managers to the here Artifactory solutions. We use Artifactory to Artifactory migration. For that, we use the replication. And for other repository managers to Artifactory migrations, we use tools and scripts in order to do that. Then we have our DevOps team switch to use the Artifactory solution to the standards as their standard repo manager. We have had so far 3 repository managers migrated, and we have a few more to come. We solved multiple pain points when that we endured by moving from the Amazon Elastic file system from the NFS server solution to the Amazon Elastic file system. We observed intermittent timeouts when we were using the NFS server solutions, when we were uploading large files to the Artifactory. We observed around 5% timeout, and when we are uploading artifacts in the file sizes of 100 megabyte ranges. After our move to the Elastic file systems, we have not seen any timeout issues, which is a huge win for us because, like I mentioned, Artifactory is in the path of the production deployment. We did a benchmark testing with the 3 storage tiers, the EFS, the NFS server solution, and S3, and I will share some of those data with you in the coming slide. There was a huge administrative task to constantly grow EBS volumes when we were using the NFS solution. And the file system had to be grown once every 2 to 3 weeks. This was a huge burden on the system engineers' time and effort. With the move to Elastic file system, the storage scale up and down automatically, elastically, and there is also a disadvantage with the EBS was we could not shrink the file system. Pay for usage. With the Elastic file system, you only paid for the amount of storage that you used. This goes back to the previous point. With the NFS server solution, we had to balance between cost and work. So if we over-provisioned the storage, then we were paying for unused storage. EFS is a highly available, durable, and a fully managed service, whereas our NFS solution was a single point of failure. It was a ticking time bomb, ready to explode anytime, and we were always afraid of that. And seamless integration. EFS uses NFS version 4.1 protocol for mounting. It's as easy as creating an Elastic file system and then sharing and mounting it onto the EC2 instance running Artifactory. When mounting Elastic file system, we can use regional DNS name rather than an availability DNS name. And with the NFS solution, it was hard to manage the DNS for the NFS server for mounting purposes. So we performed a benchmark testing and comparing the different storage tiers, basically comparing EFS versus NFS and S3. We found significant improvement in upload speeds when we were using the EFS. So we did a 2-pronged benchmark testing. We compared uploading from within the AWS So we have some DevOps tools that we have in AWS, and we found numbers of 62 megabytes per second when using EFS, and 45 and 27 megabytes per second when using NFS and S3. This was a 38% increase in the upload speeds within the AWS. We did the similar study when we were trying to upload artifacts from the on-premises data center to the Artifactory, and we saw a 33% increase in the upload speeds. The methodology that we used to do this testing was we used a 1 gig file system as a benchmark for benchmark testing, and we changed the storage tiers, and when calculated the amount of time it took to deploy within AWS and from the on-premises data center, the only variable being the storage tiers. Here, Artifactory is an enterprise solution, which helps our DevOps teams to rapid release at a massive scale. At Here, we deliver code faster, safer, and with better quality. We serve over 1.2 million artifacts, taking up about 21 terabytes of space. And all the artifacts and the repository managers are available and served off the Elastic file system. Just to give you some context here, we were having only about 300,000 artifacts using about 6 terabytes of data in the beginning of the year. So we have quadrupled our size in the last 11 months, and we are guesstimating that we will double our capacity in the next year. We have over 300 repositories, and we serve over 1,000 active accounts, active users, and bot accounts as of today. On an average, we have about 750,000 downloads and 50,000 uploads per day on an average. And our internal customer SLA for a customer base is about 99.5%. I just want to give you some of the dashboards, the cloud metric graphs that we collect for EFS to keep tab of our Elastic file system. This is all CloudWatt metrics. The important graphs are the percentage IO limit. This gives how close a file system is to reaching the percentage IO limit. Today, we use the general purpose IO mode for EFS, and we are planning to switch to max IO mode when we reach about 95 or 98% of the percentage IO limit. And this is not a dynamic change you can do, so you have to create a file system with max IO limit, copy the data, and then mount it up. The data read IO bytes, data write IO bytes gives us a tab on the read write work on the Elastic file system, and the graph above shows the burst credit balance. Since we have a large amount of space used, we have a lot of credit balance in our EFS file system. This is an Artifactory metrics dashboard that we keep an eye on. This gives the top 10 active accounts and tools that use the Artifactory, the amount of traffic that we get on an hour per day, day of the month, and hour of the day. And we use Splunk as a log management at Here Technologies. So what we do is we ship all our Artifactory logs to Splunk, and we have created this dashboard. A similar, There are two ways that we back up our artifacts. One of them is we have written, like I talked to you about, is we have created a Artifactory plugin that anytime an Artifactory is written to the Artifactory tool, it gets written to S3, and we use the AWS CLI command for it. The methodology is used in case if we need to restore some artifacts immediately. We also use the Artifactory application also can be backed up, and we back up it to the Elastic file system. We back it up once daily and weekly, and we copy it to the S3, the previous weekly backup, and then move it to Glacier for long-term retention. So Artifactory is an important tool for here technologies, and its performance, reliability, and availability is key to the working of the development and operations team within here. And AWS EFS plays a very important role in all of this. First, EFS gives us much better performance with upload speeds. Second, we are growing and consolidating, and the tool needs to be highly available. With more users and tools coming into the pipeline, and this requires high performing and reliable storage. With backups and disaster recovery, this is an enterprise tool that enables us for speed and innovation. We are looking into using the JFrog bin tray solution for our binary distribution. We are going to look into it probably next year for that purpose. And with this, I'd like to hand the stage over back to Yang. Thank you so much.
Thank you, Suret. Okay, so just to close, if you would like additional information, this is your starting point. So /EFS, here you'll find a number of resources, including blogs, white papers, TCO calculators, etc. Also this week at reInvent, we are at the top of the list here, so with the first session, but there are many other sessions available to get more information here. If we went through a quick summary of Amazon EFS, but if you would like a deeper dive, we have 2 sessions for a deep dive on the Elastic File System that I'd highly encourage you to attend. And I'm also happy to announce we have new storage training. So these are certification trainings that you can take specifically in the area of storage services. All right. So with that, we have about 12 and a half minutes left. Again, I'd like to call up our presenters here. We'll have some time for some dedicated Q&A. There are 2 mics here in the aisles that you can step up into. Just one quick comment on Q&As. Anything that's roadmap or considered NDA, we can take offline here at the front of the stage after. So with that, the floor is yours.